up. Where's the... Uh-oh. More technical difficulties. Are you getting video? Can you see? People in the back? You're good?
Thumbs up at the back.
More? Yeah? All right. Okay. All right. I think we're good now. So apologies for taking away your break, but hopefully it'll be worth it. I'm here to talk to you about Chef, Test Kitchen, Docker, continuous integration, and whole soup, but how you can use them all together to bring some tranquility to your enterprise, and to your infrastructure, sorry, and enterprise. There will be some live coding, so fair warning. I know it's been a long morning, but hopefully it'll still be interesting. So a bit about myself. I'm Arthur Maltson. I'm at A Maltson. I occasionally, very rarely, blog there. Software developer. I've always been ops curious and recently started to do DevOps full-time. So I work at Ontario Teachers Pension Plan, but today I'm going to talk to you about a problem that plagues lots of companies, large companies like big financials, to small hip startups in Liberty Village. And that problem is untested infrastructure. So if you're experiencing untested infrastructure, what might be some of the symptoms? Well, do you happen to cross your fingers before running a script in production? Are you getting paged late at night, waking up your cat? Are you finding you have some stability issues? And finally, does that automation you wrote act in a surprising way? Well, if you go and talk to your friendly neighborhood DevOps unicorn, they might tell you about something called test-driven infrastructure. And you might be wondering, well, what is that? Well, some of the background is test-driven infrastructure really comes from a popular practice in the software development world called test-driven development. Now, it's gained a lot of popularity because it's been shown to produce higher quality code that's more stable and easier to maintain. So let's say you listen to these crazy DevOps unicorns and you start practicing test-driven infrastructure. What might be some of the things you might expect? Well, you might have extreme confidence in your infrastructure and in what you deploy. You might enjoy better stability of your servers and your applications. And you might experience general operational and developer happiness. But of course, this concept of test-driven infrastructure doesn't come for free. So what does it take? Well, it does take a number of tools, and we kind of talked about them at the beginning, but let's go a bit into depth. So the first thing you're going to need is a configuration management system. In our example, we're going to use Chef, but you can use Puppet, you can use Ansible. It doesn't really matter. At the end of the day, you could even use a bash script, but configuration management system probably will work better. So in our particular example, we're going to provision a Redis server, something meaty, something real. And when you do it with Chef, it might look a bit like this, right? So we'll leverage an open source cookbook that sets up Redis already for us, and we'll just execute its recipes. So with the configuration management system in hand, the real workhorse is going to be Test Kitchen. So Test Kitchen is a test runner that's massively pluggable. So Test Kitchen will run your tests in a number of drivers. It can be Docker, Vagrant, AWS, doesn't matter. It can talk over SSH or WinRM. It can also provision the server that you're going to be testing using Chef, Puppet, Ansible, bash scripts, whatever, and then test that server with different test frameworks, like Server Spec, which we'll talk about today. But hey, if you're a PowerShell fan, check out Pester. If you love bash, Bats is your thing. And finally, you can execute those tests on any platform of your choice, CentOS, Ubuntu, and yes, even Windows in the most recent version. So from a Test Kitchen perspective, the three commands that we're going to look at today are logging into the box, just so you can poke around, and I'll show you that, hey, it's a live Docker image. Converging. Converge is a concept of taking a node, so in this particular case, it'll be a Docker image, and converging it and running your provisioning scripts, your Ansible playbook, your Chef cookbook against this node. And then we'll run verify, which runs our tests inside of that machine. Speaking of tests, this is where Server Spec comes in. So Server Spec is an extension of RSpec, which is a Ruby testing library, but it's specifically built for testing infrastructure. What Server Spec does is it uses the underlying operating system commands to verify a particular state. For example, if you want to check, is a port being listened to, you would write something like this in a very English-like syntax. And server spec will use netstat under the hood to check, is the port being listened to? If, for example, you want to see, is a service enabled and running, you can do that, and server spec will figure out which OS you're on and verify that state. Again, if you want to check if a user is there, it'll use ID on a Linux system. And finally, there's a whole bunch of other resources that we're not going to get into today, but the main one that really gives you infinite possibilities is just the command resource. Execute any command line you want and inspect its standard out, standard error, or exit status. So I'd be remiss, and it's already been talked about, if I didn't mention Docker in a DevOps days. But this particular use of Docker, in my opinion, is actually really excellent. It's a perfect use case of Docker. We want to take a machine from a known state, spin it up really quickly, do something to it, and then throw it away. And the primary reason for using Docker here is massive performance gains. So using Test Kitchen's pluggable architecture, we can throw in a driver and tell it to use the Docker driver in the kitchen.yaml configuration. And we get, right away, without doing anything, just changing what it runs in, we get a 30% or more speed boost versus using Vagrant. Because you're not waiting for the operating system to start up or anything like that. That happens right away. And finally, if you start to use caching, so in this particular case, because I don't trust the Wi-Fi, everything's going to work offline, we can actually get the full cycle of bring a node up from a known state which has nothing on it, install Redis on it, and run all of our tests. We can do that in less than a minute. So with all our tools in place, Chef, Test Kitchen, Docker, server spec, and all our limbs intact, we're going to put on our safety goggles and figure out what does this process actually look like. So to look at what test-driven infrastructure looks like, let's go back and look at how does test-driven development work. First, you write a failing test. Then, you write the code to make that test pass. And finally, especially in software development, you're going to do this frequently, you refactor. But with the test in place, you have the confidence to refactor and not be concerned that something will break. Now, I'm not religious about whether you write the test first and then the code, or the code first and then the test. Just write them close together because you'll forget what you want to test. So how does this translate to test-driven infrastructure? Well, we write a failing server spec test. We then write the recipe or the playbook or the Puppet manifest to get it running again, to make that test pass. And then we refactor if necessary. Now, from cookbooks and kind of when you provision infrastructure, there's not a lot of code, so you might not be refactoring as often. But in our example, we're going to use the Redis IO cookbook from Supermarket. Say sometime down the road we say, you know what, we really didn't like that. We want to write our own Redis cookbook. Well, you have a suite of tests. Say you have over 100 tests that verify the various states of Redis. You can just rip out Redis IO, write your own, rerun the tests, and if they pass, you can have the confidence that you can deploy that to production. All right, enough talking. Let's see it in action. So again, we're going to provision Redis from scratch. Again, everybody can see? So we have a very simple and standard chef cookbook. Of primary interest is the recipe part is empty. We just have a bunch of comments. And if you don't believe me, we'll log into the Docker machine that's currently running, and we'll poke around and see that Redis CLI isn't there, and but this is a regular CentOS machine, right? So we have Yum running. Yes, I'm on a Mac, but this is the magic of Docker. So let's write some tests. Let's write some failing tests to pretend that Redis is installed and have those tests fail, and then make them pass. So we'll go into our server spec test file, and you can see right here, there's a helpful link to all of the resources that server spec offers. You can go and read this. There's a lot of things there, especially for Windows as well, which is really exciting. But when we're setting up Redis, we expect Redis to run as the Redis user, right? So the first thing we want to check is, does the Redis user exist, right? So we just say describe user Redis, and it should exist, right? I'm speaking it out, and that's kind of what we expect to happen. The other thing we expect to happen is the location where the Redis database is going to be stored, which is var lib redis. We expect that directory to exist and to be created. So it should be a directory, right? OK, so we're good. We have that in place. Let's run our tests now, right? And so again, we logged in, and we expect these tests to fail, but that's fine. This is the idea. So we run kitchen verify, and lo and behold, we have 2 failing tests. And as I mentioned prior, we're using the operating system command, ID, to check if Redis exists. And same thing below, we check if the directory is there. OK, so let's write the code to make this pass. Again, this is Chef specific, but envision Ansible Playbook or Puppet Manifest or whatever you're using. So we'll pull in the Redis.io cookbook from Supermarket. We have to do a bit of this extra magic. I have to tell Redis.io to look for the Redis binary locally, again, because we don't trust the Wi-Fi. So I've already downloaded and stored Redis in temp Redis. The Redis binary is there. And finally, we have to include the Redis recipe to get Redis installed on this machine. Again, Chef-specific stuff. Imagine something else. Redis.io, and the default recipe, which will install Redis. OK, so now we've changed our cookbook, and we need to converge the node back into the state we expect it to be in. So this is where we run kitchen converge. And what we'll see happen is, well, Brickshelf does its stuff and so forth. What we'll see happen is the Redis.io cookbooks kicks into action. You can see a bunch of the Redis gets installed using a compilation cycle. So you can see all of the resources to get it compiled are already installed. This is the cached Docker image that I talked about. And the Redis binary is in temp Redis on the local system. And voila, we have a successful converge. And our assumption right now is, well, Redis should be installed. So let's run a kitchen verify. And fingers crossed, live demo, we have passing tests. So what this means is there's a Redis user, and the directory where the Redis database gets stored has been created. But this isn't that interesting, right? I mean, we think Redis is installed, but is it running? Is it listening? Is it doing anything? Well, this is where we write more tests. Let's write the failing tests first, and then make sure that they're failing, and then make them pass. So Redis, by default, listens on port 6379. And we want to make sure that that port is being listened to. We also want, when the box restarts, we want Redis to start back up, right? I mean, it'd be kind of suck if that didn't happen. So let's make sure that the Redis service exists and it's running. Now, the way that the Redis.io cookbook works is it adds in the port number to the name of the service, just so they don't conflict if you have multiple Redises. It's not a big deal. And we should expect that the service is enabled, right? So it should be on the system. And we expect that it should be running, right? So ideally, we want Redis to be running. And finally, as a real check, we can actually ping Redis. This is a little funny feature that Redis has using its command line tool, Redis CLI. You can send it a ping, and the expectation is on standard out, it should send us back a pong. Again, little funny thing, but it just lets you know that Redis is running. Now again, this is the Redis command line tool. These are Redis-specific things, but this is a real meaty database and something that's interesting to test drive. So we've written some tests. Let's see them fail. Right, so we run our tests, and we see we get 4 failures. And of primary interest is it can't connect to port 6379, the Redis CLI. So the Redis CLI exists, but wasn't able to connect to a running Redis. And again, this is the magic of server spec. It's using netstat under the hood to check, is Redis actually running on port 6379? Again, this is a CentOS machine, so it uses check config to see if the service is there, so forth. All right, let's make these tests pass. So it happens to be very straightforward. In this case, we just go back to our recipe, again, chef-specific things, and we change it to be enabled. We enable Redis. And now since we've made a change to the recipe, we have to reconverge the node to get it back to the state we expect it to be in. Hope everybody can see with the dark background. So at this point, Redis is already installed. We just have to wait for it to start up. That was pretty fast. And we can see here that the service got called to start. So Redis is running. Well, can we actually, is it listening on port 6379? Can we ping it? Let's find out. Run a kitchen verify. And our tests pass. So again, now we are getting more confidence that Redis is actually installed correctly. Well, it's a database, so it'd be kind of boring if it wasn't able to have data written to it and have data written back out. So as our final example, we're going to, again, use the Redis CLI. And this is the magic of the command resource. We can do anything, including write data into a Redis database. We can set the DevOps days key to is awesome, right? Oh. And in this particular case, since we're setting some data, let's just verify that the exit status is 0, right? So we want the exit status to work correctly. We expect this to pass. Should equal 0. And finally, after we've written that data in, let me move down a bit. We want to read that data back out. So user bin Redis CLI, get DevOps days, and we expect on standard out for it to return should match is awesome, right? All right. So does this actually work? Is Redis configured in such a way that we can write data to it and read data back out? Let's find out. Yes, it is. Last point that I want to make, the real productivity boost of Test Kitchen is we've been testing this whole time on CentOS. But let's say, I don't know, tomorrow your CIO says, hey, I heard about this Ubuntu thing. It's the greatest thing ever. Let's use that. Well, we just come in here. We add in to our Test Kitchen configuration telling it, hey, let's run all of these tests and everything against Ubuntu now. And without making any changes to your code, any changes to your tests, we can converge the node. And so you see the turquoise, that's CentOS. And now the yellow pops in. This is Ubuntu running, right? And we can tell it's Ubuntu running because you can see right there, right? It's installing Debian, build essentials, and so forth, right? So this is a real Ubuntu box. Again, I've installed all the resources prior to avoid offline. And it does a Redis compilation. So again, just like before, and this is, fortunately, the Redis IO cookbook supports both Ubuntu and CentOS. That's cool. But we can pull in as many platforms as we want, test our infrastructure against them, and then have the confidence to deploy this to production on Ubuntu servers rather than CentOS servers. So with the converged complete, let's check our tests and see if they're passing now in both the turquoise CentOS and the yellow Ubuntu. And they're passing. All right, back to slides. So we don't all live in our mother's basement, and we happen to collaborate with other people. So how does test-driven infrastructure help you collaborate? This is where the continuous integration part comes in. You can write your tests, you can write your cookbooks, recipes, and so forth, and then have automated build infrastructure test them. And because we're using Docker, running these tests on a server, a Jenkins server, is actually really easy. So what does the workflow actually look like? It'll look something like this. On your workstation, you'll have this tight feedback cycle of write a failing server spec, make it pass, refactor if necessary, keep doing that. You're happy with it. You push it up to Git or Subversion or Perforce. And from there, the build triggers a continuous integration task, which will spin up a Docker image, and that'll run your server spec and tests inside of Test Kitchen. And again, we can do the same thing that I just did locally on your build server. So what's the path ahead? Well, we've seen all of this stuff locally and potentially in continuous integration. What's really cool is taking a subset of those server spec tests and running them against your production infrastructure. So in this case, an example of this is something called Chef Audit, which takes parts of your server spec and can run it against your production infrastructure to verify that, hey, this Redis cluster is still set up correctly. Don't use that as your monitoring, though. That's a whole other topic. And also consider multi-node testing. So we've been using it for Redis to test master, slave, and Sentinel configurations and so forth. So if you take one thing away from this presentation, it's test your infrastructure and be a superhero. Thank you.
All right.
So just super quick, we are hiring. If this sounds interesting to you, come see me after. You can find, the slides will go up shortly. You can find more resources there. And the entire test-driven Redis that we just did is there with the commit stream and mildly good commit messages, so you can follow along.
Awesome. All right. Thanks, Arthur. Who's hungry? All right. Cool. So here's what you guys need to know for lunch, which is what's coming up next. So if you guys have any special dietary requests, you guys can see the event staff, who are the guys and girls who are dressed in black with the ties. So that's just outside. The food is going to be right where the breakfast was this morning, so just to the right of where the registration desk was. You guys are welcome to go outside and eat there if you want. The weather's nice. Just make sure you keep your badge on so that you can get back in. And the other big space where you guys can eat is the conference center. So that's where we're doing the open spaces later today. And that's just through the double doors, kind of straight ahead from where you guys entered. There's no eating in the auditorium though. And one last thing is just please be back by 12:55 in here. All right. Enjoy.